Hello and welcome to another video lesson with Mr. Roman. This is part 2 of key features of quadratics. And so we're looking here, we're going to be going to www.desmos.com, which is a graphing calculator. So we're going to go ahead and go to that website. And when you get there, www.desmos.com, you're going to click graphing calculator here at the bottom left. And then we're going to type in the function y equals a parentheses x minus h parentheses squared. The way you get to the squared here is you're going to have to click from this point. You're going to have to click shift, hold shift, and then 6. That'll take you up. And then you'll hit the 2 for the exponent, and then arrow over to the right to bring it back down, and then go plus k. So this is vertex form of a quadratic function. And it says add slider here, AHK. We're going to select all. Now, I'm going to go ahead and put A is 1 to start with. I'm going to put H is 0 and K is 0. So this function that you see right here in red, that is the parent function. And it's the same as y equals x squared. So if you notice, that black one just replaced that red one. So get rid of the black one, you've got the red one. And so here, if we have the red function and we slide the A, we can see what happens is A starts to go up and it goes down. So notice when A equals 0, so let's go ahead and put this at A equals 0. It's a flat line. It's a straight line. When A is positive, you've got an upward facing parabola. And when A is negative, you've got a downward facing parabola. Now, from 0 to 1, you can see that I'm getting skinnier in the graph. And so as I get to 1, that becomes the parent function. So where A equals 1, that's the parent function. And then from 0 to 1, you can see that as I get closer to 0, right, it's getting wider or it's compressing. And then the same is true when we look at 0 to negative 1. So 0 to negative 1, you can see that it's getting skinnier as I get closer to negative 1. And then as I get to negative 1, that's basically the parent function, except it's flipped downward or it's reflected downward. But as I get closer to 0, that graph gets wider, it gets more compressed. Okay, now let's look at what happens with H. So we're going to put A back at 1 for the parent function. And then we're going to go H slide. So we're going to see when H is 0, so let's go H is 0 here. There's H is 0. You see that the vertex is on the y-axis. I'm sorry, we need to put this as 0. So here's the parent function. When H is 0, we have the vertex at 0, 0. But if I shift H as positive, that whole graph shifts to the right. So when H is positive, or in other words, H is greater than 0, then this whole graph shifts to the right. When I have H is less than 0, so here's H is 0. When H is less than 0, the whole graph shifts to the left. Okay. So let's go ahead and put that back at 0. So we're back at the parent function here. And then let's see what happens with K. When K is greater than 0, we see the whole graph shifts upward. And then here's K 0. When K is less than 0, the whole graph shifts downward. Okay. So let's put some language to what we're looking at here on our slides. So first, we looked at A. When A is greater than 0, we have an upward facing parabola. And when A is less than 0, we have a downward facing parabola. Okay. Next, when the absolute value of A, that's what this means here, the absolute value of A was greater than 0, or I'm sorry, greater than 1, this graph was stretched. It became more narrow. In other words, it became wider. So again, let's look at this graph. As a gets greater than 0 or greater than 1, look at how this graph becomes more narrow. Or in other words, it's getting stretched vertically. Okay? And then here, the absolute value of a is less than 1. The graph became more compressed or more wide. So let's look at that again. So here, the absolute value of a, so let's put it at 1. So a is 1. When we get less than 1, look at what's happening. The graph is getting more compressed, which means it's getting wider until we get to 0. Okay, so that's looking at what happens with A. Let's look at what happens with H. So H, we saw that shifts the graph from left to right. So we're going to go back here. Now we're going to put A at 1, and we're going to put K at 0, and H is 0. So when H is greater than 1, it shifts. And then here we would say that when X minus H in this function, that shifts the graph right H units. And when X plus H, it's going to be shifting the graph left H units. And then the last one is K. So when K shifts up or down, I'm sorry, K is shifting it up or down, but that was where K is greater than 0, it shifts the graph up K units. And if K is less than 0, that shifts the graph down K units. So going back to the graph here, let's put this back at 0. So as K is greater than 0, shifting up. When K is less than 0, that's shifting down. Okay, so let's look at compressed versus stretched. So vertically stretched means the graph is getting more narrow. It's getting skinnier. So stretched here is in purple. The parent function is in red, so that's the original. And then if it's compressed, that's in green, or it's getting wider. Okay, so compressed means wider, stretched means skinnier or more narrow. Now look at example 1 in your notes. It says we're going to circle the transformations that occurred from the parent function. So the parent function here is listed as the dotted line. And then what transformations have happened with the blue line? So let's first start with what we know A to be. So we know A in this function over here is 3. Well, according to our slides, when A is 3, so A is greater than 0, that's an upward facing parabola. That makes sense. But the absolute value of A, which is going to be 3, greater than 1, that means it's going to be stretched or more narrow. So we would say that this graph or this function is stretched vertically by a factor of 3 because A equals 3. Now, we also look at what H is. So H is inside the parentheses here. So that's X plus 3. So let's go back to our slides. When we have X plus H, this shifts the graph left H units. So we are going to be shifting this graph left 3 units. So let's take a look at that. So we shifted left 2 units because H was, now this should say 2 actually. That one should say 2 as well. So shifted left 2 units because H is -2. And then K, there's no up or down shift because out here there's no plus K. So there's no shift up or down because K is 0. All right, let's look at letter B. So same thing, we're going to be looking at this function here. We've got the dotted line is the original parent function. And then we've got the blue line is the new function. And let's start again with A. So we know that A here is -1, which means that if we look at our slides, A is -1. That means it's going to be a downward facing parabola. And the absolute value of A is not greater than 1. And the absolute value of A is not less than 1. So there's nothing going to be stretched or compressed here. So it's just going to be facing upward or downward, which we would call reflected. So since A is -1, we're going to say this is reflected over the x-axis. And then next, we see that there's no h value, so h is 0, but we do see that we have a k value. And going back here to k, if k is greater than 0, it's going to shift the graph up k units. Well, we know that k here is positive 10, and so we're going to say this shifted up 10 units because k is 10. There's no left or right shift because h is 0. And there will be a part 3 for this video lesson. So this is going to be the end of part 2.